Yo, what is going on, math students? It's your teacher, Mr. Lopez, coming at you with another digital math lesson, continuing our work in Chapter 11, Section 2. We're going to talk about the Pythagorean theorem today. I know you're excited about this. I know it sounds super fancy. I know that you guys are like, what's going on with this lesson already? Well, this is a special one because this is one of those very popular math formulas that just kind of shows up everywhere when you're watching your Disney Channel shows or your Nickelodeon shows or whatever. It takes place in a school. Often in those school episodes, on the back chalkboard or whiteboard, they have the Pythagorean theorem written up, and you don't know what's going on. It looks super fancy. It's really not that big of a deal. So let's go ahead and jump into it. First off, we should understand the Pythagorean theorem. Sounds fancy, but it has to do with right triangles. If you remember, a right triangle is going to be any triangle that has one right angle. So let's go ahead and look at the formula that describes the Pythagorean theorem. All right, so this would be a really good thing to take note of in your notes. The Pythagorean theorem officially is a squared plus b squared equals c squared. You might have heard of that before, a squared plus b squared equals c squared. But what does that really mean? Well, in order to understand what this means, we need to go ahead and talk about the important parts of a right triangle. All right, so every right triangle will have two legs and one hypotenuse. Okay, so first off, whenever you have a right triangle, you should always identify this fancy looking thing called the hypotenuse. And we can tell that the hypotenuse is in fact this side because there are two main characteristics that deal with hypotenuse. All right, so fact number one, fun fact number one about the hypotenuse is it will always be opposite of the right angle. If I look at this triangle and I notice that the right angle is right here, see what I did right there? The right angle is right here, is the 90-degree angle. Opposite from it is the hypotenuse. All right, so the opposite side is the hypotenuse. Fun fact number two, the hypotenuse will always be the longest side. It has to be the longest side. I mean, if we were in regular class and I had more time, I would probably spend too much time talking and trying to prove this. But trust me, it'll always be the longest side. All right? So the hypotenuse will have these two fun facts. It's opposite from the right angle, and it'll always be the longest side. And whenever we use the Pythagorean theorem, we use the letter C to represent the hypotenuse. All right? So that's cool to know. Now, in addition to a hypotenuse, a triangle has three sides, and the two other sides are considered to be legs. All right? It doesn't matter which leg is A or which leg is B. We have to just make sure that the legs are, well, one, not the hypotenuse. All right? And two, they have to be shorter than the hypotenuse, because if the hypotenuse is the longest side, then the legs have to be shorter. Cool? All right. All right, now what I'm going to do for you is I'm going to give you guys a little bit of a shortcut, because what is true every single time that the two leg length squared added together, a squared plus b squared, where these dudes are the legs and equals c squared is hypotenuse, that is always true for all right angles. I'm going to give you guys a little bit of a shortcut to try to help you solve for these things faster. If I do a little bit of math, a little mathematical wizardry, I can solve for c by square rooting both sides, because if I square root both sides, the square root is the inverse operation of a square. They cancel out. Trust me about this. And we would find out that c is always equal to the square root of a squared plus b squared. Right? So this is a really important formula for you guys to definitely use in your notes. All right, because this will be very helpful for you guys. Okay, so if you ever want to find the hypotenuse by itself, the length c is equal to the square root of a squared plus b squared. Now, if we want to go ahead and find the length of a leg, all right, we can do a little bit of algebra, and we can solve for a or b. And I'm going to go ahead and give you guys the shortcuts. If you guys want to find the length of a leg, let's say length of the leg A, it is the square root of c squared minus b squared. Now, technically, you do not need another formula to solve for b, because it doesn't matter which one A or which one B you're solving for. A will always be a length of the missing leg. Missing leg. All right. C will always be the hypotenuse, which will be the longest side. And B will be the other leg. And that would have to be given to you. All right. So make sure that you have these written down in your notes. All right. And these will be very helpful. These are kind of shortcuts because instead of having to solve for these every single time, these are helpful. You're thinking, well, don't we need to solve for B? Well, A and B, they can be either one. It doesn't really matter as long as they're legs. Right? But the hypotenuse is a very special side. It's always going to be opposite from the 90-degree angle and always the longest side. All right, let's go ahead and do an example. Let's look at example number 1. Using the Pythagorean theorem, find C, which in this case we're going to try to find this length, the length of the hypotenuse in the right triangle at the right. Now, let's go ahead and look at this triangle. They give us the two legs. We know that these dudes are legs. 6 centimeters and 8 centimeters are the legs. But the side across, opposite of the 90-degree angle, is the hypotenuse. We're going to try to solve C. So we're going to go ahead and use this equation. We're going to say that C is equal to the square root of a squared plus b squared. We know that A is 6 centimeters and B is 8 centimeters. So we can go ahead and plug these in. So C is equal to the square root of, I'm going to go ahead, every time I evaluate, I want to put open parentheses. I want to go ahead and fill in those blanks. The first blank is A, and A was 6. The second blank was B, and B was 8. And we're going to go ahead and simplify the best that we can. This is the square root of 6 squared is 36, plus 8 squared, 8 times 8 fell on the floor, picked it up, made 64. And I get the square root of 100 after I add 36 plus 64. Now the square root of 100 can simplify to be 10. And if you can simplify, you must simplify. So it looks like the length C is going to be 10 centimeters. Cool? Cool. That worked out well for us. Let's look at standards check number 1. They want to find, they give you 2 different side lengths, and then they want to figure out the length of the third side. Now, example A says we're trying to find the missing side, and they give you the 2 legs. So if they give you the 2 legs, that means that this is going to be A and B. That means we're solving for C. So C is equal to A squared plus B squared, which is equal to the square root of 3 squared plus 4 squared, which is equal to the square root of 9 plus 16, which is equal to the square root of 25, which simplifies to be 5. So that means that C is going to equal to 5 feet. Now we can do a logic check to see if this makes sense. Well, C has to be the longest side, and this is longer than 3 and 4, so that does make sense. This actually forms a very special triangle called a 3, 4, 5 triangle, where if you ever have a right triangle, and one side is 3 and one side is 4, the other side will always be 5. Now, if you notice, this triangle, this first triangle, is also a 3, 4, 5 triangle. It's just twice as big. If I multiply 3 times 2, I get 6, and 8 times 2 equals 4, so 5 times 2 equals 10. All right, that's like a little special insider tip for you guys. Now let's look at example B. Example B says they give you a leg length. We'll call this B. And they give you the hypotenuse, which is C. So that means we need to find the value for A. I went ahead and wrote up here at the top of this lesson the formula to solve for the missing leg. So c squared, square root of c squared minus b squared, which is the square root of 15 squared minus 12 squared, which is the same thing as 225 minus, or square root of 225 minus 144. Calculator time, 225 minus 144 is going to be 81. So this is going to equal to the square root of 81. The square root of 81 simplifies to be 9, so it looks like the missing side length is going to be 9 meters. And this should make sense because the two legs, 12 and 9, have to be shorter than the hypotenuse. Cool? I think it's cool. Now, example 2 asks us to do pretty much the same thing, but they ask you to find the value of x, the missing side, and to round to the nearest inch. So this is kind of a hint that it is going to be like a non-perfect square, because they're asking us to round, which means that it's probably not going to be exactly like the square, like a square root of a perfect square. So let's go ahead and figure this problem. We have to figure out what sides do they give us and what sides do we have to solve for. First thing I want to identify is the hypotenuse. And the hypotenuse is going to be this guy. How do I know this is the hypotenuse? It's opposite from the 90-degree angle. That means that this side is going to be A and this side is going to be B. And we're going to try to solve for A. So the formula that we should use is A is equal to the square root of c squared minus b squared, which is equal to the square root of 9 squared minus 6 squared, which is equal to the square root of 81 minus 36. And if I go ahead and subtract 81 minus 36, I get the square root of 45. Now the square root of 45 is not a perfect square, but I can figure out which one is it closest to if I need to round to a whole number. I know that the square root of 45 is between the square root of 49 and the square root of 36. The square root of 36 is 6, the square root of 49 is 7, and which is it closest to? It's closer to 7. So this side length is approximately 7 inches. When they say round to the nearest inch, they want a whole number. Cool. All right, the very last example from this lesson, we're going to go ahead and look at example 4. We're going to skip example 3 because example 4 is definitely more pertinent to your homework and is something that I would ask on a quiz or a test or both. Example 4 says, is a triangle with these sides a right triangle? They're trying to figure out if we have side lengths of 12, 15, and 20 meters, is it a right triangle? And the only way we can prove this is by using Pythagorean theorem. We know, according to Pythagoras, a dude who lived a long time ago who figured this out for us, a squared plus b squared equals c squared. How do I know which side is A, which side is B, and which side is C? Well, the only thing we need to remember is that 20 is going to be C. How do I know that? It has to be the longest side. So if I plug these values in, this can be A and this can be B. It doesn't really matter which one goes where. Then that means that 12 squared plus 15 squared has to equal to 20 squared. 12 times 12 is 144. 15 times 15 is 225. 20 times 20 is 400. So if this is true, 144 plus 225 has to equal to 400. I get 369 is equal to 400. And is that true? No, that is not true. And because this is not true, this cannot be a right triangle. So the answer for this one will be no, because it's a yes or no question. Is this triangle with these sides a right triangle? No, it is not. You'll be using Pythagorean theorem to try to prove or disprove right triangle's validity. And that is it.